This is Unit 2, Topic D, and as we just mentioned in the last topic, we don't yet have rules to take the derivative of the product of two functions or the quotient of two functions. So that's what we're going to look at here. How do we handle products and quotients? I'm going to start with the product rule for derivatives, and it says that the derivative of two functions that are multiplied together, f of x times g of x, is f of x times g prime of x plus g of x times f prime of x. Or in shorthand, we might just write fg prime plus gf prime. Sometimes in words, people remember this as first function, so first times the derivative of the second, plus the second times the derivative of the first. All right, let's try this out a little bit. In our first example, we're actually going to do the problem twice. If we didn't have our new product rule, you could have done this problem anyway, just by multiplying it out first. So let's start by doing that. Still h of x, I haven't done any derivatives yet, would be 3x to the fifth plus 5x to the fourth. And now that this is just a plain old polynomial, I can easily take the derivative, h prime of x. That would be 15, and reducing the power by 1 makes that x to the fourth, plus 20, and again, reducing the power by 1 makes that x cubed. So this actually is not a difficult problem to do at all, just using even what we already knew. Since I didn't really prove to you or show you where the product rule came from, what I'd like to do here is redo this same problem, but using our new product rule, and just kind of show you that it does seem to work by showing that we get the same result. So, if we kind of force ourselves to use the product rule, I can certainly see the two things that are being multiplied together, right? Those are my two factors. So I'm just going to call one of them f and one of them g. And then I'm going to do a little bit of work off to the side. F is x cubed, and g is 3x squared plus 5x. To use the product rule, remember that we need to know both f prime and g prime as well. So I'm going to go ahead and get those derivatives right now. F prime would be 3x squared, and g prime would be 6x plus 5. So, to get h prime of x, I'm going to go ahead and do my product rule. Fg prime plus gf prime. So f is x cubed times g prime, 6x plus 5, plus g, 3x squared plus 5x, times f prime, 3x squared. From there, it's just a matter of doing some routine algebra, right? We'll distribute here, 6x to the fourth plus 5x cubed, plus distributing again, I would have 9x to the fourth plus 15x cubed. And combining my like terms gives me 15x to the fourth plus 20x to the third. And lo and behold, thank goodness, right, we really did get the same result as we did the other method. So this seems, at least for this example to be a legitimate method, and of course I'm telling you it really is, so we can continue to use it. Now, there's sort of a side effect of doing this problem two ways that I'd also like you to notice. What was easier? Well, it was a whole lot less work to just multiply it out first and then do the derivative, right? So if you can multiply first, it will save you time. Unfortunately, there are products that it's not possible to simplify or just multiply out. And so on those, we'll have no choice but to use our product rule. The problems on the next page are examples of that. So if we look at example 2, we definitely have the product. The square root of x is multiplying the sine x. But there's nothing I can do to simplify that and make it not a product anymore. So this is one where I really have to use the product rule. Let's begin by just reminding ourselves that the square root of x, we really want to think of that as x to the 1/2 power. And then we've got times the sine of x. So there are my two factors. F is x to the 1/2, and g is sine x. To do the product rule, I need f prime and g prime. So f prime would be 1/2 x to the negative 1/2. And g prime would be cosine x. Oh, let's see, let's do Leibniz notation here. So our dy dx will be fg prime plus gf prime. By the way, I do give you a lot of formulas in this class to use when you take tests. The product and quotient rules are things that I believe you really should know. So this formula is not on your test, like when you get to the midterm or the final. It is one that you will need to know. All right, so our derivative, f times g prime cosine x plus g, which is sine x, times f prime, 1/2 x to the negative 1/2. Now, there's really not a lot of simplifying that you can do with something like this. And so, as far as a final answer, all I would really expect is that you put the factors in sort of the order that we're used to seeing them. We usually see numerical coefficients first, followed by powers of x, followed by any trig or exponential functions. So this first term is in the order that I would expect it to be. Power of x and then the trig function. But this one I'd really want the 1/2 x to the negative 1/2 to be written first, and then the sine x. It's not that the way we had it was really wrong. It's just that when you get in the habit of writing your factors in the order that we're used to seeing them, it's less likely that we're going to miss something when we're dealing with complicated expressions. All right, let's try number 3. Once again, I see a product, this 4t to the 5th, multiplied by the e to the t. And by the way, if it bothers you that the function itself is named g, and we usually use f and g, you could switch to capital letters or something just to make sure that you don't kind of get confused between the f's and the g's. If it doesn't bother you, don't worry about it. So capital F here, I'm going to go with 4t to the 5th. And for g, I'll just go with e to the t. F prime is 20t to the 4th. And g prime, derivative of e to the t, is still e to the t. So g prime of t, little g prime of t, is going to be f capital G prime plus g f prime. So f, 4t to the 5th, times g prime, which is e to the t, plus g, which is our e to the t, times f prime, 20t to the 4th. And once again, there's nothing really wrong with this. I can't truly simplify it, but what I can do is rearrange the order of the terms in the last term here, the order of the factors in the last term, because typically we would probably write the numerical coefficient first, then the powers of t, and then the e to the t usually last. Of course, you could write a factored form of this, stuff like that, but I'm perfectly fine with you leaving it just like that. Perfectly good answer. All right, one more product rule problem. In number 4, we have our h of x here, and if I think about what the factors of this product are, I can really see 3 of them: 5x, e to the x, and cosine x. In order to handle that, we're going to have to actually use a double product rule, or a product rule nested within a product rule. So I'm going to start by identifying 2 factors, because my product rule can only handle 2. Let's do f as 5x e to the x, and g as cosine x. Now, just because it's simpler, I'm actually going to start with g prime first. The derivative of cosine x would be the opposite of sine x. That one's simple and done. The problem with f is that it is itself another product. So I'm going to do my product within a product. I'm going to identify 2 factors here. And again, just to distinguish, let's call those capital F and capital G. And I'm going to say that little f prime would be capital F capital G prime plus capital G capital F prime. And let's see. Capital F is 5x. Capital G is e to the x. So f prime here is just 5. And g prime is still e to the x. So little f prime is fg prime, 5x times e to the x, plus g times f prime. I'm just going to write that as 5e to the x. All right, we finally got down to the little f prime and little g prime that we needed in our original problem. So the derivative we want, h prime of x, is little f g prime plus little g f prime. All right, I'm going to fill everything in here. F was 5x e to the x, and g prime was the opposite of sine x. G was cosine x, and little f prime was this whole thing, 5x e to the x plus 5e to the x. Now let's talk a little bit about final form of the answer on this one. Generally speaking, I'm fine with a multiplied out form, and I'm fine with a factored form, but I'd like you to avoid ones that are kind of half and half, right? This is not fully multiplied out, because cosine x is factored out of those 2 terms, but it's also not fully factored. There's nothing factored out of everything. So let me show you 2 acceptable forms of this one. One option is to just multiply everything out. This would give me negative 5x e to the x sine x plus 5x e to the x cosine x. And again, notice I'm just rearranging the order of the factors to be what we're used to seeing. And then plus 5e to the x cosine x. So there's a completely multiplied out form of the answer. Absolutely acceptable. The other possibility would be if you prefer a factored form. It looks like we could factor out a 5e to the x from all of these terms, which would leave me minus x sine x plus x cosine x plus cosine x. also acceptable. Okay. But again, notice this is now fully factored. That 5e to the x has been factored out of all of the terms. What I don't want to see are these kind of half and half ones. So fully multiplied out or fully factored. All right, so there's our product rule. We will come back in the next video and talk about the quotient rule.